In this video, we're going to look at taking the second derivative of functions defined parametrically. So normally we have a function y defined in terms of x. So y is yx, it's a function of x, and then we are asked to work out dy by dx, and that's just sort of standard differentiation. With parametric functions, rather than having y defined in terms of x, we have y and x both defined in terms of a separate parameter. So y is given as a function of t, and x is given as a function of t. And now to work out dy by dx, we can't do this directly because we don't know y in terms of x, but we do know y in terms of t and x in terms of t. So we can use the chain rule to say that dy by dx is dy by dt multiplied by dt by dx, and then use the fact that dt by dx is 1 over dx by dt, to rewrite this as dy by dt divided by dx by dt. So this is the first derivative for parametric functions. So dy by dx is dy by dt divided by dx by dt, which just follows from the chain rule. But in this example, we want to look at the second derivative, so d2y by dx squared. Well, that just means d by dx of dy by dx. And again, using the chain rule, this is the same as d by dt of dy by dx multiplied by dt by dx. That's the chain rule. We differentiate with respect to t and then multiply by the differential of t with respect to x. Okay, now we actually already know what dy by dx is from the method above. So this is the same as d by dt of dy by dt divided by dx by dt. Again, using the same trick that this is dt by dx is 1 over dx by dt. This is the sort of long formula. Thankfully, we don't really have to remember this formula necessarily. If we're doing an example, we can just follow the chain rule. So here's an example, e.g. x equals 6 plus 2t squared, y equals 5t plus 4t cubed. So let's do A, find dy by dx. Okay, well dy by dx is dy by dt divided by dx by dt. And dy by dt, we just have to differentiate y with respect to t. We get 5 plus 12t squared, straightforward differentiation, and dx by dt is, well, differentiating 6 gives nothing, differentiating 2t squared gives 4t. This is 5 plus 12t squared over 4t. Okay, now it might be slightly easier to simplify this at this point. This is 5 over 4t plus 12t squared divided by 4t is 3t. Okay, so that's our first step, dy by dx. That's this simple first differential. Now for the second differential, we're going to do, let's say we have to find, our part B is find d2y by dx squared. Okay, and using the chain rule, as we said before, this is d by dt of dy by dx multiplied by dt by dx, which is d by dt of dy by dx divided by dx by dt. This is the same formula that we'd written down on the left hand side. Okay, So thankfully we can fill in most of this now, because the numerator is d by dt of dy by dx, which we know is 5 over 4t plus 3t, and dx by dt we previously worked out was 4t. This is all divided by 4t. Okay, so the numerator d by dt of 5 over 4t is minus 5 over 4t squared, and differential of 3t is plus 3. This is all over 4t. Okay, and this all, you can get this into one fraction. This is, well, minus 5 over 16t cubed plus 3 over 4t. Now we can put it all into one fraction if we want. Let's put it all over 16t cubed. We get 3 over 4t. We multiply the top and bottom by 4t squared. We get 12t squared minus 5 over 16t cubed. Okay, so that's how we work out a second derivative when our functions are defined parametrically. We just use the chain rule twice. There's a formula you can use, but you don't really need to learn it. As long as you're familiar with the chain rule, you can just sort of work it through, as I did.